If you've ever used Nissan's factory utility track system, you know it's actually a pretty good idea. You can slide tie-down points anywhere along the bed rails in the truck and tighten them down by hand to create a secure tie-down point pretty much anywhere you want. Most manufacturers like Toyota, Ford, and Chevy also have a system similar to this. The problem, if there is one, is that every time you want to move one, you have to loosen it, slide it, tighten it back down by hand, and then maybe you realize you put it in the wrong spot. Sure, it's not hard to adjust them, but just because the product is good doesn't mean it can't be improved. And that's why I decided to design my own Speed Cleat, which hopefully works even better than the factory one. Hopefully it works, period. Only time will tell. This video is sponsored by JLC CNC, who was generous enough to manufacture the parts for this project. Nissan's factory tie-down is called the Speed Cleat. Despite its name, it's actually medium speedy. It locks into the track by tightening a threaded knob, and while it works well, it's a little bit more tedious than it has to be. So my idea was pretty simple. What if it worked more like the seat clamp on your bicycle? As demonstrated on this bike in my kitchen, you flip one lever open, slide the tie down wherever you want it, and flip the lever closed, and then you're done. No threading, you can just move it and lock it wherever you want. And who doesn't love a little side quest? While I was redesigning it, I figured I might as well make it do something else too. So I added threaded mounting holes to the face of the tie-down so it can double as a mounting point for a MOLLE panel or other accessories. I really hope I'm saying that right, but I have a feeling I'm probably not. That way the tie-down isn't just taking up space in the rack, it actually becomes a part of a storage system if need be. And like most bad ideas, this one started in CAD. I'm using FreeCAD because I'm broke. The only real challenge here is making sure the dimensions match the constraints of the utility track. So really, two things need to happen. I'm going to call the piece within the track the clamping face. As long as the clamping face sits within the track, but isn't too small that it'll just slip through, the clamping mechanism should work. The part where the actual tie-down is should be large enough to loop hooks through and clamp against the outside face of the track, but should still sit below the plastic portion of the bed cover, which juts out a little bit past the track. And obviously it should be strong enough to hold a couple hundred pounds, which is what the utility track is rated at. Lastly, I designed it to have both a horizontal and vertical post for a hook to pass through. Sometimes you use a ratchet strap to tie something down to the bed, and other times you want something to compress against the cab, and that's just life. So I designed the tie-down for both use cases. The backing plate, clamping face, and all of the tie-down points are about 5/16 inch thick aluminum. According to a simulation done in FreeCAD, they should be able to hold several hundred pounds of tension, which I think will be plenty. Aside from those 2 points, the cam lever should be pretty forgiving. Too loose and the tie-down slides around, just thread it in a turn or two. Too tight and you need the grip strength of a competitive rock climber just to close the lever, back it out a turn. After shaking off the rest in CAD, I finally had a design I was happy enough to test out on my fancy, new but heavily used 3D printer. Before spending money on machined aluminum parts, I wanted to make sure the design actually fit the truck. So I fired up this 3D printer, test printed this cute little cow since it was my first time 3D printing, and then made a full prototype of the assembly. This thing prints furiously fast. Also, this is the part where I ask you to hit the like button because I did kill 3 trees in the making of this video. Now obviously I wasn't expecting the plastic tie-down to hold any real weight, but the goal wasn't strength, it was just to make sure everything fit the way I thought it would. There's a big difference between a CAD model looking right on a computer screen and an actual part fitting inside the utility track. Once I made sure it fit, I tested it to failure, I guess you could say. It broke with what felt like about 10 pounds of force. The prototype showed just a couple of things I wanted to change, so I tweaked a few clearances, adjusted the shape of the backing plate, and printed another version. And at this point, everything slid into the track smoothly, and the cam lever had plenty of room to operate, and the tie-down worked exactly as I wanted it. I already love having a 3D printer because now I can test ideas in a few hours, and it's a whole lot cheaper to discover your mistakes in plastic than it is in metal. At this point, I sent the CAD files over to JLC CNC, and they make it pretty easy. You'll get an instant quote before you submit your order, and then a real engineer will review your files and let you know if they foresee any conflicts. A couple days later, a box of beautifully machined aluminum parts showed up at my door. And even for something as simple as this, it's always a little surreal seeing something that existed only on a computer screen turn into an actual part you can hold. The machining quality came out great. The edges and the finish are clean and everything fit together exactly as I had modeled it. This is a good thing because explaining that my own part didn't fit would be kind of an awkward sponsored video. Assembly is pretty straightforward. The T-bolt of the cam lever slides through the small backing plate. Then I place a spring over the bolt to make it easier to use. After that, the clamping face with the tie down, and then finally the lever gets threaded on. Once everything is adjusted, the lever provides enough clamping force to lock the tie down solidly into the utility track. With the lever open, the tie down slides freely down the rail, and once the lever is slipped closed, it's locked in place in about a second. This way there's no twisting, tightening, or wondering if you've threaded enough. Threaded holes also make installing accessories a whole lot easier. And they're pretty strong. Here I'm pulling up on the ratchet strap with about 700 pounds of force. In order to really test these out, I have to remove the shelf angles that I previously installed for my bed rack and rooftop tent, which is very unfortunate because I'll have to reinstall them to go camping in 2 days. Check out the video on that build if you haven't already. It was a pretty fun one. White dip. Got it.
It's actually so funny.
They're not quite as slick as these new tie downs, so maybe I can make a shelf angle out of a similar cam lever system in the future. Anywho, it's really easy to move the part around within the track and take it out when it's not needed. The spring keeps everything preloaded and also pushes the clamping face away from the track when the lever is released. And this is what allows the whole assembly to pop loose instead of having to manually pull the pieces apart to get it out of the track or just to adjust it. Enough fun, time to reinstall the shelf angles. Here I am test fitting my M-word panel that I mentioned earlier. I have no idea what I put on here, and it's a little small to be useful for much, but I think it serves as a good proof of concept. Alright, so good news, I just used my tie down for the first time and no one got hurt. I have big dreams of building a steel workbench in the near future so that I can stop catching my wooden workbench on fire while I'm welding. Bob from Craigslist sold me this 2x2 steel tube, which I plan to use for the legs. I like using these ratchet straps with the cam lever releases. I guess I just have a thing for cams. This is one of those times when having both vertical and horizontal legs on the tie down come in handy. I call this a successful first prototype. I think there are still a few small things I can improve if I was to make a next revision. The first is the size. I intentionally made this relatively compact, but after using it, I think I could make the tie down face a little larger without interfering with the bed cover. I'd also probably change the shape of the lever. It works fine, but I think there is an opportunity to make it a little bit easier to grab with gloves, and I don't think it needs to be quite as large. But overall, this solves exactly the problem that I had set out to fix. It is quicker to reposition than the factory cleat. It adds some extra functionality, and honestly, I think it looks nice, and I'm proud to have designed it myself. A huge thanks to JLC CNC for helping me bring this design off my computer and into the real world. Side note, I've also made custom PCBs through JNC before I ever had a YouTube channel, and I've always had a good experience. If you enjoyed this project and want to see more custom design parts, please let me know what I should build next. Thanks for watching, and I'll see you in the next one.